thanks everyone for joining. I know it's late, energy is low, so I'm really happy to see you here. Well, and welcome to us explaining that and why we think that there is definitely a paradox when it comes to performance testing. With me, Sonja and Frank. A bit about me. I'm Sonja Nesic. I'm in testing, a test engineer. I'm in testing for almost 10 years now. And if you want to connect with me, then you can reach me on X, formerly known as Twitter, under the handle Testing I Do.
So, thank you. My name is Frank, and everybody who was really enthusiastic about hearing all these AI talks. This is me according to DALL-E. So, if you're thinking of jumping on the bandwagon, like hold your horses, it's not that brilliant yet. So a bit about where we work. So we work at an e-commerce company in the Netherlands. We have about 700 engineers, and together we maintain about 1,400 microservices. The area we work in is in the basket, checkout, and order flow, both customer-facing and all the backend systems that are needed to implement that functionality. And as you can imagine, we interact with a large portion of our landscape. And that large portion, like everything, comes together and is exposed to the customers. And because we are customer-facing, performance matters for us. And it matters a lot. And we're going to tell you a story about how we look at performance, what the state of our performance setup was, and how we ventured into something that we think is way more optimal.
So as Frank already said, yeah, we were quite on a journey for the past 2 years. And I want to first tell you something about where we began, where we were those 2 years ago. So maybe this setup is familiar to most of you, but we were back then still running in an on-premise data center. This also meant that we had a so-called performance and test center that was managed by the specialized team. They were taking care of all the infrastructure that was needed for executing the performance test. And we as feature, Scrum teams, innovation teams were in charge of the script. So we provide the script, they take care of the infrastructure, and that's how a performance test is executed. It runs against our application, and this application runs in a certain pre-production environment that, of course, talks to all of its dependencies. This is a really simplified overview of how many of those dependencies actually our application needs, but it's a lot. And this is basically how our performance test setup looked like. And that meant also that our performance tests were running end-to-end. The same way as on production, our application needs to depend on a chain of dependencies, the same way it depended on the pre-production environment. And that also means that our performance test was, of course, putting load on our system, but inevitably it was putting load on all the other systems as well. This meant that we were testing all the things. So our performance test, of course, touches other systems, which sometimes might not be the best way ahead. And this was really a recipe for disaster. And we were struggling a lot with this size of an ecosystem. There were problems all the time. Where would they occur? And they would occur quite often, is a couple of places. First of most all is like the network. Right? So there can be issues with connecting to these dependencies that we need. But it can also be not just on the first hop of our landscape, it can be on the second, third, fifth hop. And understanding where something went wrong and why is our performance testing failing was quite a gruesome task to do. The second thing that can fail, systems of their own, right? So our system might be actually up and running and all happy, taking that load. But if it needs a system that is struggling, throwing errors, maybe actually going through a maintenance that we were not aware of, or just going down because they released something that is not performing well, well, that of course impacts also us. And the third place, and the most difficult one to troubleshoot and to follow up, is when there is data absence, data misalignment, or data corruption. For the previous two problems, it was quite easy, still took a lot of effort and time, but you could really easily spot what actually broke. When it came to the data issues, it was really hard to try to understand why did our performance test run fail. And this actually consumed a lot of time.
Yeah, so if you have a vast microservice landscape and things are failing in the third, fourth, fifth, and layer of dependencies that are actually working together to fulfill a task, and you need to debug those problems, you can imagine it's quite a monumental task. So you need to start digging into logs, metrics, all these kind of things. And all the man hours we spent on that, it was an unbelievable cost factor. Also, it is possible, of course, to manage test data throughout your whole landscape. But if you have 1,400 services, making that work and tying everything together is also a monumental task. It's really, really difficult to actually get that done. So the second point of very costly affairs is that if you want to have a performance test that behaves like production and the results are actually projectable to your production environment, you likely want to have the same size scaled system as you have on production. So if a company grows, the offer grows, the customer grows, the interaction grows, then production grows to mammoth scale, but then also your pre-production or your staging environment needs to grow to mammoth scale. Again, an extremely costly factor. And looking at the whole endeavor and looking back the last 5 years, we found that the amount of human effort and the amount of money we paid for the resources was extravagant, and we felt that this was really cost ineffective. So we needed to do something. But as often, in companies, often you need a trigger or a disaster to get something started. Luckily, we didn't have a disaster. We had a trigger. So the company decided, okay, we have an on-premise data center, but we're going to the cloud. We want to have all the magical scaling and things that the cloud promises. So we chose a cloud vendor, and we knew, with regards to performance testing, we don't want to keep on keeping a mirror environment. So the idea was to move away from that, and we are moving away from that. So staging and production will not be alike anymore. We're just abandoning that whole idea. And by abandoning that, we needed to, by the knowledge that we wanted to abandon that, we needed to rethink our ways. And rethinking our test strategy then all of a sudden became a really important thing. And Sonja will tell you what things we encountered while looking at that.
Yeah, thank you. So as Frank said, a lot of thinking happened then. We started looking like, okay, this is how performance testing looks today. We have opportunity here. Let's use it. What we want performance testing to look like. And what we realized is there is a huge paradox if you start thinking about performance testing. All of a sudden, we were saying, okay, the problem at the moment is performance testing is really unreliable, really expensive. And somehow, as we were talking about all the problems, it was like really a blast for the past. Like, isn't this the same problem that functional testing was facing like 10, 15 years ago? And we said, like, this is a really big no-no. And luckily, in a lot of companies, steps were made. And in some, unfortunately, it's still the case. But we actually made a massive evolution happen in the domain of functional testing, right? In the functional testing, we often are able to make reliable and cost-efficient and implement cost-efficient test strategies. And in performance testing, not yet. In functional testing, there is years and years of standardization happening. There is a vast amount of knowledge present in this space. But in performance testing, not yet really. And if you just look up best practices functional testing, you will find so many articles, so many knowledge, so much talks and conferences. Not really for performance testing. There are tools here and there. Just write a script and run a load test and a stress test, and yay, you're good to go. But really about the details of the implementation, it's a lot of time missing. So the more we talked and think about it, we realized that testing is not always testing, apparently. And while functional testing became part of our definition of done, and we can't imagine releasing to production without saying somebody wrote some functional test for it, this wasn't, at least for us, the case in performance testing. We were like, yeah, we run them when we think that maybe, I don't know, and when us, as for an e-commerce, the Black Friday week comes, then we for sure gonna do it. But it was definitely not part of the definition of done. And while functional testing in the last decade, evolved a whole ecosystem per language. Like if you're a back-end developer, you will not use Cypress to test your application. If you're a front-end developer, you will not write JUnit test, because why? It's so far apart, world apart from what your production code is written in. This was not yet the case for performance testing. So all in all, we felt that performance testing is just this whole other species. Luckily, the more we talked about it, we realized we have the shoulder of giants to stand on. There was this learning in the domain of functional testing, and we realized that we can actually just reuse that learning. And some of the key points of that learning were, in the functional domain were, you should test what you control. You should not test the whole chain all the time. You want your tests to be reproducible. If they fail, you want them to fail because your application is misbehaving. You want to trust the contracts, because that's the only way that you can achieve this reproducibility and also this reliability. And you need to control the input and the output. That's the only way to achieve this stability. And this all meant that in the functional domain, we were moving more and more to isolation. We were moving more and more to the left.
So, apparently we were shifting left. But with shifting left, we lose a certain level of trust. So we based our trust on the deliveries that we made, on the balance that we found of what we test where. So by shifting left, we break something there. We move away from something that we were used to. But we knew we wanted to do it. We know that people-wise and resource-wise, it wasn't cost-effective. So we needed to find new ways. And the question we needed to answer is, okay, but what is actually enough? When do we have enough, in this case, confidence? Which means, how can we replace what we've had with something else that is less costly, but gives us the same feeling of security, gives us the same amount of control? And, not last, the cost versus benefit. I mean, the bigger you grow, the more investment, the more money everything costs, the more people you have. So you really want to pay attention to this cost factor. But then the hard part comes. So we were all used to doing things in X way. And we decided as a company, okay, we want to change. We need to change. We cannot keep on doing things the way we did. But people got anxious. People got fearful. This is our truth. This is what is good. This is how we test. You're taking something away from us here. So this meant we needed to have a huge change of perception, and not of one person, but of basically the whole engineering community. So we needed a cultural change. Literally, the mindset of people needed to change. And this is really, really hard, and takes a lot of time. So the mission is to regain trust. And perhaps also paradoxically, at first for me, shifting left means shifting right. Right? We are in the center, that's where we find our balance. We move something a bit to the left, and we're off balance. So something needs to move a bit to the right as well to make sure we feel whole again. So how do you do that? Well, there's a couple of tools in the industry that allow us to do it. Site reliability engineering is one of them. So the perception of a customer of when the function you deliver is good enough. So we can start measuring at the front end in whatever way. And this is a contract in some sort, right? We have the contract with the people, the parties we deliver a service to, that this latency, this volume, etc., will be okay for us to handle. Another thing is distributed tracing. We move something from more to the left, closer to the code. But runtime, we need to gather enough insight to make sure that integrations still work, right? Because what we give away is testing the integrations. We can't do that in the build anymore because it's in isolation. So something needs to be added runtime to make up for that. Another possibility here is that you're going to look at your release strategy. Canary releases, red, green. I heard something I didn't know at the conference yet, which was a dark deployment. Sounds really interesting. There's all kinds of ways to adapt your release strategy to become comfortable. Another one is testing on production. For everybody who does A/B testing, it's not this big a leap. mentally, we changed the perspective that we had, that a release can just be an experiment. And experiments are done in a controlled manner, and we can see them fail, but we do that statistically with such a small target group that it can be okay. I'm not saying this works in every branch, but in e-commerce this definitely works. I wouldn't try this in automotive or in the airplane or aeronaut kind of thing. That would be like really risky. But testing on production for us is really a viable option. And now we know everything that we want to include. So we know the options that we have to gain trust on the right. We know that we want to isolate. We know how functional testing helped us. And this gave us all the ingredients that we needed to start our journey.
So we did. And we already knew that this is going to be a monumental task, because eventually we wanted to change everything about performance testing. So we wanted to change where we run the test, how we run the test, how we look at the test, how we integrate with the environment or not. There was a lot of things ahead of us. And what we knew for sure, that we cannot be successful unless we make adoption easy. That was crucial for us. And we thought of a couple of things that were important to make this adoption easy. One of them was that we wanted to reduce the cognitive load of engineers, because what we had back then is that an engineer that is constantly working with Java or with Kotlin code needs to go to a JMeter tool to puzzle together some kind of script that under the hood does some things. It's quite a jump from your current day-to-day context. So we wanted to reduce this cognitive load and bring the tooling actually closer to what engineers just work with on a daily basis. We also had a goal, and we wanted to make performance testing just an integral part of our way of working. It needed to become part of our definition of done. So this is, this is where we started, and we said we need to break down this journey. We need to make some step-by-step changes. We want eventually to change all the things, but let's start at the beginnings. The test center that I mentioned on the start of the presentation, as I said, was running in the data center on-premise. It had a deadline. It's gonna die and be turned off in month, year, so-and-so. So that was a good way to start, right? There's an ambition, you have a deadline. After this moment, you're in charge, you need to make choices. So that was, for us, a logical place to start. Let's just first not yet think about all the dependencies and the environment. Let's just focus on the test. What it meant? Well, the first one, where are we gonna and what's gonna execute our test, was a no-brainer. We're moving to the cloud, so we're gonna just utilize the cloud to have that infrastructure and provide us the infrastructure to execute these tests. It can scale to the need that we have, so some of our services have a lot of load, like 12,000 requests per second. Some of them only have 10, 20. With cloud, you can achieve any of that because it allows you to do so. Second thing, our engineers work in the JVM ecosystem, so they are used to working with Kotlin. So we wanted to find a solution that is actually really close to them, preferably Kotlin. I'm not saying that you should do that, but whatever is close to your engineers. We just decided that we want to work with the HTTP client that we also use for our production code. Why would we dare make a different choice? So if we can use the same HTTP client that we use for our application on production, let's do that. Insights. This is an interesting one. Out there, a lot of the performance testing tools, what you also saw in the previous talk for K6, they provide some kind of reporting. While there's nothing wrong with reports, we thought, if on production we're using Prometheus metrics to determine is our application healthy and how are we doing, why wouldn't we use these same Prometheus metrics to check the health of our test run as well as how our application behaves during the test run? Plot this data to Grafana, because in that way we can also track and monitor how this execution goes throughout time. And Frank already mentioned tracing, utilize OpenTelemetry. So at this moment, we're still talking to the rest of the landscape. It was important to be able to troubleshoot if there are issues. And the OpenTelemetry and tracing allowed us to easier find which of the hops down there in the landscape actually had a problem. What we ended up with is we realized that a performance test, especially if you're running it in the cloud, on its own is a really simple concept. You don't need a lot of knowledge there. And we looked at a lot of open source tools. Eventually, we ended up actually writing our little performance testing library. It's just a couple of lines of code because there's not a lot of complexity to it. And we were really happy and ready for the next step.
Yes, so after realizing that it was in our benefit to make performance testing super easy. And super easy meant it related to people in their day-to-day business. So venturing out from writing your feature and your test for your feature to writing a performance test for that feature, the difference would be really small. As Sonja said, Gatling is a performance test tool, great. JMeter, also great. K6, great. You have all of them. But going from, I'm writing Kotlin 99% of the time, and then to remembering how locusts work, or the Gatling DSL works, or whatever, this is a massive step. And this is one of the reasons performance testing never got part of our flow. So this eventually made us say, okay, if we can wrap something around the HTTP clients that we use that communicates metrics to the platform, maybe that's in our best interest. And it was wildly successful. So, but back to the environment. As we said, the test tool was replaced. Step one, we have something that works for the people. Step two is, well, this is still running in integration, right? We have our test tool in the cloud. We have the application under test still in DC on-premise. And it was still connected to all these underlying services. So we didn't achieve the idea of isolation and reproducibility. What a word. So, what's next? Functional testing, most of my career, we knew, okay, we're going to mock out everything that we do. And how do we do that? Well, we figure out where the boundary is to the outside world, things that we no longer control. And over the wire, these are mostly described in an API. In code, it might be an interface or something like that. Preferably, we have some formalization of an API in form of an API specification. And this is our favorite one at the moment. You might hate or love REST, but the only thing that's really out there to describe these REST contracts properly is the Open API specification. But this still is the functional part, right? Within your functional test, this is what you usually tend to look at. The shape of the API, how you communicate with it. But performance tests bring something extra. They bring SLAs. Because we're interested in, if there's this much load, what will the latency of our app be? We are interested in the error rate under a certain load. And this is the contract that we have with our customers, the non-functional contract, next to the functional contract. So those together form the whole of the thing that we need to know to do performance testing over the wire. So, how do we do that? If we test our REST applications or web applications that talk to another web service, we use WireMock to test that. It's a JVM library, and it allows you to return stub responses based on a certain request that comes in. So in practice, it translates to something like this. If the test tool calls our system under test, well, it's likely that we want to pay for an order, and we want to create an order based on a basket for a certain customer. And in that basket, there will be certain products. So this makes it kind of hard, because the ID of the basket, the ID of the person, the ID of the product, the ID of the offer need to be perfectly aligned. So we need to be able to control that world just like you would do it in memory in your functional tests. And we are using WireMock to actually do that. So our application, for all its dependencies, calls this mocking system, and the mocking system returns response B if request A arrives. And we would no longer need all these underlying applications. So how do we do that? Well, in memory, it's kind of easy. You use your favorite mocking library. Over the wire, you need to somehow transfer data from the test tool to the mocker instance. And what we did is we utilized our tracing setup, and the test tool was sending a header, like I'm in this scenario and performing this action in that scenario. Distributed tracing forwards that from the application under test to the mocking instance. The mocking instance is provided with contextual information, and it understands that for request A, it now needs to return B. Added benefit is, because until now, this was pretty much an over-the-wire functional test, as you could say. The benefit is now that we can introduce latency here. if we hammer our application and our dependency becomes slow, we want to know how our app behaves. Is it getting slower? Is it influenced? But also, if dependencies start continuously failing, what does that do to our application? Okay, so the idea is nice, right? We isolate it. We bring it to our staging environment, because probably we'll always have one. But the rest of the world can't just go along with us. So if to the staging environment we would deploy only a system that would return mocks, stat layer wouldn't be able to buy anything anymore. Because we know our staging environment is still used to do integration tests. So we need to also facilitate that purpose. So what we ended up doing is implementing backwards compatibility. And in our case, that means that this mocker setup is a transparent proxy whenever requests are coming in from Statler to the system under test. And this, again, is done by utilizing the headers. So if the test tool talks to it, mocker knows, I need to respond with mocks based on the scenario and the action. If Statler connects to us, those headers are absent, and it will just forward all the requests, like it would do normally, to the backend dependencies. And this facilitates also chain testing, because we would love to not have it, but sometimes you just have changes that span the whole landscape at once, and you really want to get some kind of feel how that works, both performance-wise and functionally. So this helped us to actually cover all our past scenarios and supply with everything we need to do things in isolation.
I'll try to speed up a bit, looking at the time. Yeah, then we arrive to the third step, and that's actually the step that we are at the moment still in. Because we say, okay, Statler still might sometimes with some actions disrupt our application under test while our performance testing running. So we wanted to see, can we do this and take this even a step further to achieve more control, more flexibility, and more independence. But since we are locked in with our cloud provider, there are certain deployable units that we are not in control of. So there are certain cloud-managed components that we cannot just spin up at ease when we want to. So those we see now that they will always be shared between our actual application running on staging and being used by Statler and a new instance that we wanted to spin up only for the purpose of our performance test. So this is at the moment the setup that we are still exploring and experimenting with, that we want to just spin up a new isolated version of our application that only talks to Mocker, no Statler is aware of it, and we run the performance test against it. However, this does come at a certain cost. So as you can imagine, there is a certain knowledge that you need to have, setups, infrastructure. The pipeline becomes a bit more complex. And we want to first still measure, does this really help our engineers? And do we really have so many problems if we just keep the previous version? So we're still exploring this option. We'll see, is it worth the investment or not? More on it later. And yeah, it was a long journey. And we are not yet done with it. But we definitely can say that we had a couple of achievements that we're really happy about. If you remember, we started with being completely out of control. The environment, it was just not something that we could influence. Now we do feel that we are in control with our Mocker instance. If there are errors, they are there because we are actually wanting to test the scenario, what happens if the rest of the landscape just blows up. From a lot of uncertainty, we kick off that test and then we hope for the best. Now we know if we run a test and there's something wrong, it's because we did something wrong. From a really uneconomical setup, we are actually now running a really economical setup where we only run the test and the infrastructure that we need. From being ineffective and just running those tests constantly and losing a lot of time on troubleshooting and understanding, we became now effective with those performance tests. And from performance testing being the ugly duckling in our test strategy, it actually became a really pretty swan.
Yes, and we've got some closing notes for you. So what we realized as a company is that we were reasoning about quality, but that was actually 90% of the time was only including functional correctness. It wasn't including non-functional correctness. And as you can imagine, for a shop, revenue and latency correlate really strongly. So for us, it was actually really odd that we never combined that and made that, it gave performance testing the same place with regards to quality as functional testing. Another interesting thing we thought of is if you take away the influencing latency over the wire, injecting errors over the wire, which, by the way, looks a whole lot like chaos testing, then a performance test, when you squint, looks a lot like a concurrently ran functional test. Because we use the contract, we input A, we make sure we get back B, and we can do assertions on the outcome. So maybe, well, I'm really interested in, is we can evolve this to something that we do a mini load test, always in the build, if cost effective, as our functional regression test. Another thing is that developer productivity was never as high on the radar as I think it should have been. We always used Gatling, but there were like only 2 or 3 people in a product that dared to look at it when the holiday season came again. When we, a large portion of the company started using Locust, well, a lot, which is Python, which there's nothing wrong with Python. There's nothing wrong with Locust. But if you're used to a certain flavor and you love working in that certain language and ecosystem, people tend to try to stick with that. So why not facilitate in that human need that we recognize? And another thing is that if you think about how did it get here? How did we learn so much about functional testing, but didn't we cross that boundary to non-functional testing? Why didn't these lessons transfer? And I think a lot of this has to do with that in companies, we've organized ourselves in business units, in whatever kind of subgroups, then in products, then in teams. And these boundaries and crossing communication between these boundaries is really hard. And I think in some cases, if you don't pay attention as a company or as an industry as a whole, it can become really harmful. And with that, I want to leave you with your own thoughts. And thank you for your time. Thank you for being here.
Hi, thanks, it was really interesting. I was just wondering, it wasn't explicitly stated in your presentation, but are you applying this like methodology of like performance testing each service throughout the network of services? So it's like in your tree there you had like customer, product. Are each of those having their own mocker and their own?
Yep.
Okay.
Yeah, exactly.
Because that makes sense. Because then that helps a lot. You like it's different type of performance. You have like relative changes. Like this service is slower than it was yesterday, but it helps you isolate or. Like
yeah, and indeed what Frank mentioned about the SLAs, we drive those from productions and from the contracts that we have really with those teams. Like what is your promised response time, and that's what we incorporate then in Mocker. Like respond with me within the 90th percentile of your response time on production, and let's make sure that we make it as representative as possible.
Yeah, and an interesting realization is also that, I mean, you cannot judge us for systems that we depend on to become slow. But you can judge us for saying, okay, now that's taking long enough, and provide with an alternative response to your customers. So this is why we really said, okay, focus on what you control and take care of all the contextual things that can happen. Make sure you provide a decent output.
Thanks.
This was really interesting. One thing I'm wondering about, the library that you built custom for yourself. You mentioned you're a huge company. Who maintains this library?
So
group of enthusiasts.
Always hard within the company, because our company is formed based on OPEX teams, operational excellence teams, and those are grouped with engineering managers. And it's really hard as a company to get something horizontally maintained. But we have a couple of platform teams, and what in practice happens if something is incubated in a smaller area and it gets adoption in other products, then at some point you get a mandate to have that moved to a platform team, and that will start owning it. But it's a bumpy road.
Yeah.
Did I understand it correctly that you do the performance tests directly on your production system?
No, on pre-production still, yes.
Okay, okay. Well, then the next question is not necessary.
And so what we aim to do is that our pre-production or staging environment, as we tend to call it, only has one node of every application running. And this makes it really cheap. And functionally, if you want to test simple things, you only need one node in 99.9999% of the time. And this is how we try to keep costs for those environments to a minimum. Of course, the environment can scale. Let's say if you have a database, you also want to stress the database. You also want to see what the breaking point is of that storage system. So then your application needs to be able to scale, but then you're still testing what you own. So there are some caveats and more things if you really start diving into it. But it's all focused on being effective, both with people that you have and with the money you spend on resources.
Okay.
Thank you for this talk. I have two questions. So I would like to ask, do you integrate this performance test in CI?
Yeah.
Okay. Can you expand more on that? Like how do you monitor this, like this test, and how do you get output from it the next morning?
Yeah, thanks. So we are still tuning a bit how the pipeline should look like, and like having debates when is it useful to run and when not. At the moment, our agreement is then whenever it's merged, then we do kick off the test automatically. And since we do have the Prometheus metrics emitted from the test run, you can also add alerts that then via OpsGenie also alerted the team in the Slack channel, or just have a KPI check. Okay, this is healthy enough, so you don't fail the pipeline, or it was, as in the pipeline succeeds, or no, this was not good enough, so then you just basically fail the pipeline and say there is something you should look at as a team.
Yeah, so
thank you.
It's about, it's multifold, I think. So I always tend to say, so we emit metrics to the platform that we also use to see if our production systems work correctly, right? So our staging instance emits those metrics. So we can have alerts on those metrics, just like we have alerts on those metrics on our production platform, because I really believe that you want to be as lazy as possible. And that means that, I mean, okay, there are people who for fun look at dashboards all day, that's fine. But I think that's not very useful use of your time. It's way more useful that if a test fails, either your CI/CD pipeline sends you an email or some alert comes into your Slack saying, okay, you just crossed the boundary, you should look at this release because something is off. So we try to utilize as much as the pro infrastructure and pro way of working for our performance tests.
Super, thank you. So you basically answered my next question, which is like, how SRE really like help you with monitoring and enhancing the system? So yeah, thank you.
Yeah, you're welcome.
Any more questions?
Oh, thanks
Thank you.
again. Yeah.
It was a great presentation.